Oh man, what do I do when I've got exponentials in different bases? Well, I'm solving for an exponent here, and I can't write 19 as 2 to a power, at least not very easily. So what do I do? Well, if I remember what Mr. Allen said, he's awesome and everything, and he told us that logs help us solve for exponents. So what if I were to loop and swoop this bad boy into log form? So I'd have log base 2 of 19 equals x. Well, I can do something pretty sweet. I can either do change of base, which we learned in the last video, so log of 19 divided by log of 2, or if you have one of the newer calculators, hit the math button, and then the button right above it says alpha, and then hit math again. That's a shortcut that's going to give you something that looks like this. It'll be log, then it'll give you a little box and another box, and you can just write log base 2 of 19 in there. How nice is that? And what you're going to end up getting for x is going to be approximately 4.25. So whether you do it with the math alpha math and you get this nice little log base there, so we can type in whatever you'd like, or you do change of base, because if you have a TI-83 or even some of the TI-84s, you don't have this nice functionality here, so you will end up having to use change of base, which is fine. Just make sure you close off your parentheses, otherwise you're going to have a bad time. And make sure you're plugging it in and checking to make sure you get the right answer. As you sit there and, oh, I know how to plug in my calculator, it's fine, no big deal, and then you make a mistake on the test. So practice. All right, we got another one. Again, getting a little more complicated here. We have 5 to the x plus 5 equals 15. I can't write 15 as 5 to a power. No, 5 to the third is 125, not 15, right? You're thinking multiplication there. So I can't write them with the same base, but I can loop and swoop to solve for an exponent. So I'd have log base 5 of 15 equals x plus 5. Keep in mind, when you're dealing with logs, it's just a number, okay? Log base 5 of 5 is just a number. That's it. It's helping us figure out what 5 to what power gives me 15. So if I evaluate that using either change of base or my math alpha math thing that I just learned about, I can do that in my calculator and get 1.68 rounded to the nearest hundredth equals x plus 5. And then I can go and just subtract 5 to solve. Now I'm just dealing with a normal algebra problem that has decimals, no big deal. You can handle it. And I get x equals negative 3.32. Awesome. That wasn't so bad. Just one extra step of subtracting that 5 from both sides there to solve for x. Sweet. Alrighty, we're at it again. We're solving for an exponent, but this time we got some addition on the left-hand side. That's weird, because I can't write this in log form yet, but what if I were to subtract 10 from both sides? Now I have 5 to the x equals 39. Now it looks like something I had before, and I can write it in log form. Log base 5, because that's the first one I start with, of 39, because that's the next one I pass, equals x. And I can just math alpha math that bad boy or change the base. You know, either one is going to work. You'd have log of 39 over log of 5 if you did change a base. And what I'm going to get for x is approximately 2.28. Make sure you're rounding correctly. You know, you'll probably learn rounding back in first or second grade, right around the time you're probably learning how to tie your shoes. And I'm pretty sure all you know how to tie your shoes, so you should remember how to round numbers. Alrighty. So again, we're just adding to like what we did in the last problem here. Just another additional step. As you see, the exponent's a little bit different here, but we'll deal with that in a sec. First, let's subtract that 9 from both sides. That sounds like an awesome idea. So I got 4 to the 2n equals 8. Sweet. Now there are actually a couple options here. You may notice that you can write 4 as a base 2, squared, and 8 as a base 2 to the third, but you might not notice that And you know what? We've got our calc right now. Might as well use our calc. We're in that mode. Let's put it in log form. So we got log base 4 of 8 equals 2n. So let's evaluate that log base 4 of 8 right off the bat, and we're going to get a decimal, a nice one actually, of 1.5. And that's going to equal 2n. Well, what am I going to do next to solve for n? Well, I'm going to divide by 2. And I'm going to get n equals 0.75, or 3/4. Either way is cool. Awesome. Man, these logs are just so useful and helpful. How did you ever live without them? All right, the next one. We've got a 10 to the x minus 4 equals 63. I think I'm ready to rock and roll with this. Loop and swoop. Log base 10 of 63 equals x minus 4. Now, when it's log base 10, your calculator actually defaults to log base 10. So you can just type in log of 63. If you wanted to just go with the same mode that you've been doing and just do log of 63 over log of 10 or the math alpha math and put a 10 in there, that's cool. I'm just trying to save you time. You could just type in log parentheses 63 on this one since it's a base 10 and your calculator is set up to be base 10 with logs. Well, whenever I do that, I end up getting it's 799, so it becomes basically 80 if I do 2 decimal places, equals x minus 4. I'm going to add 4 to that, and I'm going to get 5.18. Sorry, 5.8. There we go. Cool. So 5.8 is my answer. Lovely. Nice job solving.